Okay, so today we're going to look at ions, do some review, and then start looking at how do we write ionic formulas. Okay, so if you remember with an ion is all it is a charged particle. Okay, and you can have two types of charge. You can have a negative or a positive charged particle. So if we get a positively charged particle, we're going to say that's a cation, right? And I remember our way to say this is, remember it's a positive because it's a cation, and cats have paws, so it's a positive charge. And it has, if it's a cation, it has lost electrons. Okay, so it's a positive, it's a cation, it's lost electrons. If you have a negative ion, it's called an anion. Okay, and a negative anion has gained electrons. Now, even though that seems counterintuitive, remember that we're gaining and losing electrons, and electrons themselves have a negative charge on them. Okay, so if I lose electrons, I'm losing negative charges and becoming more positive. If I gain electrons, I'm gaining negative charges or becoming more negative. Okay, so where do these electrons come from? You just can't, they're not just magical. You can't just create electrons. What happens is elements react to gain, lose, or share electrons to become more stable. All right, so elements gain, lose, or share electrons to become more stable. Certain elements lose electrons, metals, and other elements, nonmetals, gain those electrons. Okay, and if we remember back to our atomic radius and ionization energy, a lot of that has to do with that. How much control do those elements have over those electrons helps determine if they gain or lose them. They gain or lose them, though, to become more stable, and they're most stable when their valence shell is full. Okay? So how do you become stable? Well, you become stable by having a full valence shell. And for most of the elements on the periodic table, our valence shell accounts for 8 electrons. Okay, these are the S and P electrons in the outermost energy level. Okay, so we got those S and P electrons in the outermost energy level. So some examples. So if we take a look at oxygen, oxygen has electron configuration 1s2, 2s2, 2p4. So it's got the outermost energy level, in this case is the second energy level. It's got 2 s electrons, 4 p electrons, so oxygen would have 6 valence electrons. Okay. And what it can do, it can either lose those 6 valence electrons to have a full first shell, or it could gain 2 more electrons to have a full second shell. And obviously gaining 2 is easier than losing 6. So oxygen will gain 2 electrons to become an oxide anion. Okay, oxide anion with a -2 charge. Okay, something that would be the opposite of this if we look at, say, a metal. Say we have calcium. Actually, I might do a smaller metal. Let's say we do, let's do sodium now. So sodium's electron configuration is 1s2, 2s2, 2p6, 3s1. So it has 1 valence electron. Okay, so it's going to lose that 1 valence electron to cut it sodium ion with a +1 charge. So sodium ion. All right, now, so there's where our electrons come and go from. So, sodium might react with oxygen because sodium gives up electrons where oxygen takes those electrons. And that's where our electrons are going to come from when we're, it's not just sodium loses an electron, it loses it to something else. And oxygen just doesn't gain electrons, it gains it from something else. So let's take a look at writing ionic formulas. Okay, so writing ionic formulas. Okay, the most important thing is the charge on an ionic compound must equal 0. Okay? So in other words, my positives have to equal my negatives, so they have to balance out. If I lose 3 electrons, something else has to gain 3 electrons, okay? So you can't have an uneven charge when you're writing ionic compounds. Okay? So let's take a look at some of these. So let's say we have sodium. Well, sodium has 1 valence electron, so it's going to go to a +1 charge. And then let's say sodium pairs up with something like nitride. Okay, nitride is nitrogen as an anion. Well, it has a -3 charge. So in this case, well, my charges don't add up to 0. I have a +1 and a -3. So in order for this to be a balanced ionic formula, I need 3 sodiums per every 1 nitrogen or nitride. And this would be sodium nitride. Sodium nitride. Balance that out. Let's do another one here. Let's say we have calcium. Calcium has 2 valence electrons, so it's going to lose those 2 valence electrons and go to a +2 charge. And let's say calcium pairs up with fluorine. Fluorine has 7 valence electrons, so it's going to gain 1, go to a -1 charge. Well, +2 minus 1 doesn't add up to 0, so we need 2 fluorines. So we have CaF2, or calcium fluoride. Okay. Now another way to do this is called the crisscross method. If we look here, if we take the charge of this and we cross it down here, it tells me how many sodiums do I need. How many sodiums do I need? Well, I need 3. How many nitrogens do I need? I need 1, Na3N. Same thing works down here. If I crisscross the charge, it tells me how many of each atom I need. How many calciums do I need? I need 1 calcium. How many fluorines do I need? I need 2 fluorines, CaF2. Now, so there's basic writing compounds, and I think we were doing good with that the other day. Now here's where we kind of got some tricky stuff when it started talking about polyatomic ions. So let's talk about polyatomic ions real quick. So polyatomic ions, their name kind of tells me what they are. Well, poly means many, atomic means atom, so they're many atomed ions. Okay, or they are a group of atoms that act as one ion. Okay, they're a group of atoms that act as one ion. In other words, there's multiple atoms together that are acting together as one thing. So here's a list of polyatomic ions. And I'll highlight some ones that we use a lot. So one of them we use a lot is nitrate, NO3 with a -1 charge. Hydroxide we use quite often, OH with a -1 charge. We use sulfate a lot, SO4 with a -2 charge. Carbonate we use a lot, CO3 with a -2 charge. Phosphate we use a lot, PO4 with a -3 charge. And we also use ammonium quite often too, NH4 with a +1 charge. All right. There are some other ones. Oh, and acetate. We use acetate as well quite often. Okay, so what it means is these formulas act together as one thing. So if I put this in a compound or something, let's take a look at hydroxide here. So hydroxide is an OH ion that has a -1 charge. So the OH group has a -1 charge. And they always pair up together. It's always 1 oxygen per 1 hydrogen that make a hydroxide. Okay. It's not 2 oxygens per 2 hydroxides or hydrogens or anything like that. So in a compound, how does this work? Well, let's say I have calcium. Calcium has 2 valence electrons, so it's going to go +2. And say we pair it up with hydroxide. Well, hydroxide has a -1 charge. So in this case, to equal out or balance out these charges to get to 0, I need what? I need 2 hydroxides. So if I wrote it like this, that doesn't tell me 2 hydroxides. What it tells me is what? 2 hydrogens. Well, hydroxide is always OH. Okay, it's not OH2 like this. This is not correct. What I would want to write it at is calcium, parentheses, OH, with 2 outside the parentheses. Now, what does that tell me? It tells me 2 hydroxides. Because every 1 hydroxide I have 1 oxygen, 1 hydrogen, so if I have 2, you distribute this in, you have 2 oxygens and 2 hydrogens. Let's take another look at here, one more look with this with polyatomic ions. Let's say I have magnesium. Magnesium is an alkaline earth metal, has 2 valence electrons, so it's going to go to +2. And let's say it pairs up with phosphate. So phosphate is PO4 with a 3-. Okay, so again, that's one of those polyatomic ions I highlighted up here. Okay, well, right now we see that, hey, my charge is not balanced. Okay, I have 2 magnesiums, I have 3 +2 magnesium and a -3, that doesn't add up to 0. So my common factor between the 2 of these is 6, or you can also do the crisscross method. I'm going to need, what, 3 magnesiums. And I'm also going to need 2 phosphates. Now, important thing with phosphate here, I cannot change phosphate from PO4. Phosphate is always PO4. So if I need 2 of them, this is not equal to PO2. That is not the same thing. Those polyatomic ions act as one group. So if I need 2 phosphates, I need 2 PO4s. So how I'd write that is I'd put it in parentheses, I'd say PO4, and I'd put a 2 outside of it. This is magnesium phosphate. Okay, so hopefully that clears up some issues we were having with writing ionic formulas and the polyatomic ions. So the big thing with polyatomic ions is anytime you have a polyatomic ion and you need more than one of it, you've got to put the polyatomic ion in parentheses and how many you need outside the parentheses. Because these polyatomic ions have a set formula. You know, if you look here, phosphate is PO4, but phosphite is PO3. And those two things act differently. That one oxygen different matters. Another example, nitrate is NO3. I need 3 oxygens. Nitrite is NO2. Those are 2 different compounds or 2 different chemicals. So polyatomics, their formula never changes. Okay? Nitrate is always NO3. Acetate is always C2H3O2 with a -1 charge. Okay? So that's important, and that's where those parentheses come into play, saying how many of each ion do I need. All right, so hopefully that helps clear up anything about why chemicals react, what are the ions called, and how do we write those formulas.